Hello, my dear students. I would like to state about Physics Revision Class 12 for Chapter 3 CBSE Board Examination, though it is written in 2021 but still valid. Few topics of these chapters have been deleted and which are mentioned in the last of the page. Here you should know the relation between charge and current, charge, current and time. I equal to Q upon T, or I equal to dQ upon dt, or Q is equal to integral I dt. So charge also depends on time as well as current depends on time. Now drift speed. For drift speed, you have to define drift speed, define relaxation time, and on what factors drift speed depends upon. Also the points, if temperature increases, what changes will occur in a drift speed. To derive the relation between drift speed, relaxation time and electric field as Vd equal to small e, capital E, tau upon small m. Here small m is the mass of an electron, and this one small e is the charge of one electron, that is 1.6 into 10 to the power minus 19 coulomb. Capital E will be electric field intensity in Newton per coulomb or volt per meter. Tau will be relaxation time. So E equal to V upon L also. V is the potential difference, L is the length of conductor. Now next point, to derive relation between current, drift speed and electron density, that is small n, number density or number of electrons per unit volume, as I equal to small n small e a Vd. Here it is mentioned. Current density, define current density. Is it scalar or vector? Write its expression and unit. So J equal to I upon A, it is a vector quantity and unit is ampere per meter square. Derive relation between current density, electric field and conductivity of material. So derive J equal to sigma E. And you can find out by mentioning I is equal to NEA Vd. A is the area. From that formula you can get J equal to sigma E. Conductivity and resistivity. So write the relation between sigma and rho. So conductivity is the reciprocal of resistivity and sigma equal to Ne square tau by m. Explain the resistivity of conductor increases as temperature increases, and while the semiconductor it decreases. It is the point C of serial 4. It can be explained as the temperature increases, the collision frequency increases, so relaxation time decreases, and resistivity is reciprocal of relaxation time. Hence resistivity increases for conductor. For semiconductor, as temperature increases, covalent bond breaks, so more number of free electrons are coming out. In this way electron density increases, and we know rho is inversely proportional to n also. Therefore resistivity decreases or conductivity increases as temperature increases. Next point, serial number 5, Ohm's law. Define Ohm's law. State whether R is constant or does not depend on V and I. If R depends on length of a conductor or wire, area of cross section, nature of material and temperature, and resistivity depends on nature of material, type of material and temperature. Draw a plot showing variation of potential difference versus current. For GAAS, you can show the variation like this. We can show for conductor resistivity and temperature variation, as for semiconductor, it is resistivity versus temperature as this graph, rectangular hyperbola. Okay. For IV, plot current versus potential difference like this. For GAAF, so gallium arsenide, this resistance temperature coefficient for semiconductor is negative. Next, we mention here explain for two resistances R1 and R2 which one will be higher, by showing I on y axis and V on x axis. Between I and V or V and I, it is a straight line and slope will be R1 if V on x axis and I on y axis. So higher the slope, higher will be resistance. But if axes are changed, like current on y axis and potential difference on x axis, then smaller the slope, higher will be resistance. In which case resistance is constant. Resistance is constant for a small value of resistance. As V changes, I changes accordingly, so it is constant. How resistance depends on temperature, and a very important numerical based on this. So say at temperature T1 resistance is R1 and at temperature T2 resistance is R2. So R2 equal to R1, 1 plus alpha T2 minus T1. Now what is alpha here and what is its unit? Alpha is the resistance temperature coefficient and its unit is per degree Celsius or per Kelvin. Plot the graph showing the variation of current and potential difference for conductor and semiconductor. For semiconductor, the plot between I and V is like this. This is cut-in voltage and variation forward voltage and current in milliampere. So this is the graph between I and V for semiconductor. And for conductor, a small value of resistance, it is a straight line passing through origin. Now next, mobility. Define mobility and express it in mathematical form. Write it as SI unit mobility. Vd directly proportional to E. Vd is the drift speed, E is the electric field intensity. So Vd is equal to mu E. This is serial number 7.A. And SI unit is Vd upon E. E has the unit volt per meter. So meter square per volt second. Which one has higher mobility, electron or hole? Electron, because mobility of electron is greater than hole. Derive relation between mobility and relaxation time. So mu is equal to Vd upon E. Vd is equal to E tau by m divided by E. So E tau by m. This is the relation. E tau upon m equal to mobility. Discharging and charging of cell. Now, for discharging, potential difference for terminal potential V equal to E minus IR. E is the capacity of a cell. R is the internal resistance. For discharging, this is the equation for charging when a cell is getting charged. So in this case, V equal to E plus IR. Define internal resistance and list factors on which it depends. Internal resistance of electrolyte. It offers the resistance offered by the electrolyte. So it depends on various factors like concentration. Higher the concentration, higher will be internal resistance. Temperature. Higher the temperature, lower will be its resistance. Area of cross section. Higher the area of cross section, lower will be internal resistance, and separation between two electrodes. So greater the separation, greater will be R. Write the equation of cell in discharging condition. It is told V equal to E minus IR, and in charging V equal to E plus IR. Plot a graph between V and R, between E and R, and between V and I for discharging of cell. So between V and I, V on y-axis and I on x-axis like this. So this is the graph straight line and its slope is minus R. R is the internal resistance, and on x-axis, this is x-axis, this is y-axis. On x-axis it cuts and the value I equal to E by R, because V equal to 0, so I equal to E by R. On y-axis it cuts as V equal to E. For the graph between V and R, R is the load resistance, and the shape of graph is like this, and this value is E. Origin R. This is potential difference. So in this graph we can get the equation as V equal to E minus IR and V equal to IR in the circuit. So E minus I into small r, therefore I equal to E upon R plus R, R plus R. I equal to E upon R plus R. So as R becomes infinite, I will be 0. And we have to find the relation between not this V and R. So we can write the expression as V equal to E minus IR equal to E minus I equal to V upon R, VR upon capital R, or V is equal to E upon 1 plus R by R. So as R becomes infinity, the denominator becomes 1 plus 0. So V equal to E. And when R equal to 0, denominator becomes infinite, so V equal to 0. So plot is shown earlier. Now for between E and R, E and I, between E and I, so cell, this is the straight line parallel to current axis. Now next, cell combination, and numerical is very important on this plot. V greater than E or less than E or equal to V can be equal to E or V less than E. V less than E when cell is connected with the load resistance, as this is the cell internal resistance, here is the load resistance capital R, internal resistance, cell EMF, current is I from positive to negative. So in this equation, V less than E, and when in open circuit current is 0, V equal to E. Okay. Now for series combination of cells, E equivalent equal to E1 plus E2 plus E3 and R equivalent R1 plus R2 plus R3. For parallel combination, E equivalent upon R equivalent, E1 upon R1 plus E2 upon R2 plus E3 upon R3, like that. And for cell polarity change in series, E equivalent is equal to N minus 2M multiplied by E, and R equivalent NR. Okay, it is mentioned here in serial number 9, point number B. Now Kirchhoff rule. There are two rules. One is junction rule and another is loop rule. Junction rule is based on conservation of charge and loop rule is conservation of energy. So in junction rule, summation I equal to 0, and in loop rule, summation V equal to 0. That is, in junction rule, algebraic sum of current entering the junction equal to algebraic sum of current leaving the junction. And in loop, closed loop, the sum of voltage rise and sum of voltage drop in a closed loop equal to 0. So numerical may be asked on this formula, this Kirchhoff rules. And here Wheatstone bridge is included this year. So draw circuit diagram and show using Kirchhoff's rule. When no current flows in the galvanometer, the product of opposite resistances across galvanometer is equal. So in PQRS quadrilateral, you can show it when Ig equal to 0 by using Kirchhoff's rules. When galvanometer and battery position are interchanged, there will be no effect on balancing of Wheatstone bridge. When will the Wheatstone bridge circuit must be sensitive? It will be sensitive when order of resistance is same. What is the purpose of galvanometer in the circuit? To measure the deflection, and at null position there will be no deflection. Now meter bridge and potentiometer, two topics are deleted this year. I hope you understood. Thank you very much.